about. On the other hand, if you wanted to do something like this with Kafka, you'd really have to lean on like partitions somewhere in the middle here to
Right.
do right. Hey, everybody, welcome back to another episode of Rethink Connectivity, where we talk about our favorite cloud native messaging system, NATS. And in this episode, we're going to continue our discussion around NATS and Kafka with my friend Jean-Noel Moyne, who's our relative NATS and Kafka expert. And I'm going to be drawing, just like last time, some diagrams as we're discussing some of these things, and Jean-Noel is going to talk. So, Jean-Noel, do you want to kick us off by talking about how consumers work in Kafka versus NATS?
Yes, certainly, Jeremy. So, in to set the stage a bit, let's make sure we got the terminology right, because there's potential for confusion between the terms as we use them in Kafka, as they used in Kafka, sorry, and as we use them in NATS Jetstream, especially with regards to the term consumer, right?
Mm-hmm.
In Kafka, you have consumers, which means a client application that is reading messages from a topic stream, right?
Mm-hmm.
A consumer is only one guy going against the data. And, since there are many use cases where you actually want to distribute the set of messages within a consumer to a set of consuming applications, Kafka has what's called consumer groups. And a consumer group is essentially a layer on top of the consumer where the uh, topic, right, the data is split into multiple partitions. So that's the Kafka partitioning. And then client applications essentially are assigned one or more partitions uh, from the list of partitions of the topic, and they work against the subset of those partitions that are being assigned to them.
Okay.
In Jetstream, it's a little bit simpler because we have only one concept, that of consumer, and the client applications that get messages from those consumers are just called client applications. Um, so essentially, what we call a consumer in NATS Jetstream is the same as a consumer group in Kafka, with the difference being that consumers in Jetstream can be shared by any number of client applications at any given time without having to have partitioning in place, right? It's an important distinction, and we'll talk more in depth about it in a further episode a little bit. But it's important to understand that in order to distribute the processing of messages in a topic between client applications with Kafka, you need to use partitions. And there's a static mapping according to something called a key that publishing applications can specify when they publish the message to the topic. And essentially, you can only have one consuming application um, at a time per topic, right? Or sorry, per partition of a topic. And that's because of, I will explain later, how the acknowledgement, or rather lack of acknowledgements, that you have in Kafka as you go through the messages works. So in Jetstream, right, you can add and remove client applications to the consumer, and the consumer will automatically, evenly, and using according to demand, right, distribute the messages between those consuming applications.
Right. So you can really easily scale without having to worry too much about the internals. Scale these kind of consumers up and down, and Nats will kind of figure out the right thing to do because all this consumer state kind of lives on the server side, and these consumer applications, um, I'll just call these apps or client applications. These guys are pretty much stateless, right? And so they can kind of go about their business and not really assume too much because Nats takes care of that. On the other hand, if you wanted to do something like this with Kafka, you'd really have to lean on like partitions somewhere in the middle here
Right.
compute, right? Um,
Exactly. You need to know ahead of time how many partitions you're going to need. And, essentially what it means is that because the problem is if you had to change the number of partitions each time you added or removed one client, it would be problematic because you have to, do operations to change the number of partitions. It doesn't rebalance the data. So, I mean, long story short, typically you want to avoid having to always change the number of partitions. So what people typically do is they quote unquote over partition in the sense that,
mhm,
as I said, right, the limit is that you cannot have more than just one single client application, consumers in their term, per topic partition, right? um, Essentially topics in general are not meant to be shared by multiple applications at the same time. I'm simplifying a bit here. The only
mhm,
way this works is because of partitioning. So what you do is you say, oh, maybe I will need to have like 100 maximum number of consuming application at once against this topic. So I set my number of partitions to the highest possible, that the high watermark, if you want, right, of
mhm.
100 different partitions, and then let the consumer group distribute those partitions among the number of client applications that are connected to the consumer group at that point in time, right? Um, Comparatively, the consumers in Jetstream, so none of that, no partitions. You can add and remove client at any time. There's no need to change anything, right?
Mhm.
And also, if you look at it, the consumer groups in Kafka, they don't really have state other than how many partitions there is, which client applications consumers are currently connected, not, and which partitions they've been assigned to, and things like that.
Mhm.
While the consumers in Jetstream are stateful, and that's
Mhm.
also a difference. And we'll start going to that into the details as we describe, the difference between consuming messages and, for example, using a queue as a topic and things like that. But like I said, the consumers or the consuming applications, client applications in Jetstream do not need to persist any state at all. While in Kafka, the omen remains a little bit on the client applications to persist what's called an offset, right? Which is where they are in the position wise, right? In the topic or the topic partitions that they are working against.
Okay. So you're saying these consumer client side applications they kind of have to keep what offset they're at?
Yeah,
Okay.
right. So, and going into a little bit describing how you consume messages, what options and functionalities are available to you with Kafka, right? When you say, I want to consume messages from a topic or a topic partition, right? Kafka, you get to choose only whether you want to start from the start of the topic, right?
Mhm.
So you get everything. From the end, you get nothing until there's a new message put in, right? Or from a specific offset, right? So a sequence number and partition number, right? Then messages are delivered to you in order, right, within that partition, because it's a log, right? Comparatively, with Jetstream, you have a lot more options as to, for example, you can start replying messages from, right? You certainly can do from the start, from the end, right, and from a particular sequence number, kind of like an offset, except you don't have to worry about the partition in this case, right? But you have other options as well that are specific to Jetstream. One being the last message for a particular subject, or for all the subjects that are
Mhm.
in the stream. The other one being the first message for a particular subject, or whatever, all the subjects or a set of subjects that are in the stream. And you can also say, I want to start from the last hour, from so over a period of time. So you can say, play back everything for the last 2 hours, 10 minutes, whatever it is, right?
Mhm.
So you have an aspect of being able to control over time where you start to replay from. There even is a fixture which is kind of unique, but useful in some cases, sometimes for doing debugging and things like that, which is when it replays the data or feeds you the data from that stream to your client application, whether it sends the data as fast as you can consume it, or that other option, which is that it can meter it and only replay it at the same rate that it was initially put into the stream to start with.
Yeah, which can be really good for debugging real-time applications. What were the other things that you mentioned? So we have start, we have end, we have period of time, sequence number. You mentioned a couple others there that.
Yeah. So first message per subject
Mhm.
and last message per subject. So you could do, and finally, right, the last thing as well, we should add at the time while you're there, you can specify a subject filter, right? As we
Right.
mentioned in previous video, which you should look at if you haven't yet. But uh, Jetstream is subject based addressing aware. So you can have more than one subject into a stream. And when you iterate or create a consumer, you can specify, as we said, a filter to say, give me all the subjects, either explicit individual subjects themselves or using the wildcards, all the subject that match a certain pattern in the wildcarding of the subject. So that essentially means that it's like a view, right? From an If you think about SQL, right, where you're
Mhm.
creating a view to another table by doing a select on top of it, so filtering some of the rows in the table to that view, is the same thing. It's not materialized view; it's actually a proper view, right? The
Right.
stream doesn't create another copy of the messages just for that. It does keep, however, just like a view, some amount of state as to if you're iterating over a view in a database, uh, there's some amount of state there as to where you are over your iteration of that view. It's the same with the consumers in Jetstream.
Yep. Yeah, and I think that some of these options, it seems like a lot of flexibility. And I'm curious, like I know I've experienced as we've been engaging with some of our customers that are doing things at the edge, where this can be like really important, right? Especially things like first or last message per subject. I remember working with a particular client of ours that they had a consumer here and then they had their application over here, and imagine that this isn't just like web scale, but that this is like at the edge. And so this thing could be really anything. Let's assume that it's an IoT device that can like um, do some sort of beep or alarm or something like that. It would be useful if there's a stream that exists here in the cloud, maybe that I could send like remote commands to. Maybe it's going to be like command dot then the command like type, and I don't know, then the actual or maybe it's command and then like the device ID and then the actual like command type. Um,
Right.
and imagine you want this device to beep every time I send it a command. But this device is on like 5G. It could fall in and out of service. What if I told this thing to beep like 5 times? Command 1 2 3 4 beep. Um, and I want all those commands to still live in this stream, but this consumer really probably doesn't want if it lost connection and then came back and got 5 beeps, it probably doesn't want to beep 5 times. And you can go and like deduplicate that inside of your application, or you could simply set up like give me the last message per this particular subject. Or
Right.
filter on it. And that way I'm only going to beep once or I'm going to do something once because that's really the only that's from a business logic standpoint, that's how I want it to work. And so you could kind of
That's
see some
right.
of this intermingling of like some of the NATS constructs to like real business logic. Whereas I think with Kafka, it takes a much more different approach where it's going to give you have these options of where to start, and it's just going to give you a fire hose of the stuff, and then your application figures out what to do with that.
That's right. There's no filtering.
Right.
It's all or nothing kind of.
Yep.
And the last message per subject, first message per subject is a whole slew of use cases, are pretty common, well known if you come from the traditional messaging system
Yep.
uh, that fit that thing. So um, another thing to mention briefly is it's not a query, but there's actually an operation that you can do directly on a stream, which is a get operation.
Hmm.
So this rather than like a view where you say, give me all the messages starting from the first one with a subject on that subject, right? All the messages, the last message matching this set of topics, right? You can do something which is like a direct get in a key value, right? Which is actually how the key value on top of JSON works, which says, give me directly the message for a specific subject, you know, without wildcards. Give me directly, very quickly, what is the current last value or what is the current first value for that subject in the stream. This is very interesting because this is an operation that's very fast. It's literally, if you know NoSQL databases, like the difference between doing a get and some form of query, right? Gets are always very fast. The order of magnitude is tens of microseconds when going over loopback, for example, to avoid measuring the network latency. But it'll give you an idea of the type of latency that you can get out of a get operation. The other option, obviously, is to create consumers. And I want to mention there's actually two forms of consumers. They're kind of related. One is what we call a durable consumer, and the other one is ephemeral consumer. So the difference between a durable and an ephemeral consumer is a durable, you create the consumer once, and then you leave it there. Often you create durable consumers administratively. The applications don't actually themselves.
Yo, get out now. Nope. Okay, try
No
that
worries.
again.
Yeah, I'll start again at durable and
Yeah, that'd be great.
ephemeral. Right. Okay. So you can actually create two kinds of consumers. Uh, Almost the same thing. One is called a durable consumer. So that means that you create the consumer and you expect the consumer to be very long lived. Typically, durable consumers are created administratively rather than by a client application, though they certainly can be. And the idea there is that a durable consumer, there's two use cases for it. One is super simple, which is the distributing of the messages that come from the stream through that consumer amongst a number of client applications. And the other one is, for example, you have an application, it's the only one to consume from that stream, right? Or from that getting its own copy of all the messages in the stream. But it's transient. So that application can come, disappear for a while, restart, come back later, an hour, whatever it is, right? And again, you don't want to have to persist any state on the application. So you want to be able to, application comes up, start iterating through the messages currently in the stream, right? Maybe at the end, it gets to the end and waits for any new messages.
Mhm.
Then that application crashes or gets stops or get disconnected, whatever. And you want to that when it restart the application later or gets reconnected after a certain amount of time, it picks up automatically from that consumer where it was, right?
Mhm.
Uh, you'd use a durable for that. The durable is stateful, remembers where you are, which message has been sent to the client, and acknowledges it or not. And you don't have to worry about persisting any of that state in your client application. Ephemeral is, in a sense, a durable, except that if there's no client application connected to it for a certain amount of time that you can specify, it automatically gets cleared up. Typically, ephemeral, the use case is you have an application, there's a stream, and that application wants to get its own copy of all or a subset of the messages in the stream right there, right now. If the application stops and restarts, it probably wants to start again, re-receive all the message currently in the stream from the start or from wherever you decide to, for example, rebuild its state, right?
Mhm.
So it's kind of like a non-shared, just for yourself, and you're gonna reuse it all the time. A little bit like as I said, durable is like where you would create a view on a table, versus an ephemeral is just simply a query over which you return, iterate of the result set. And if you stop and restart your application, you're gonna make the query again and iterate over the result set over again.
Yeah, that's a great example, and just to kind of give you guys some more like concrete examples of like durable versus ephemeral here. I had a video where I created a whiteboard, like just like I'm drawing right here, but it was a live whiteboard, right? And so in this case, we were using NATS on the front end via JavaScript, and I was creating ephemeral consumers. To be able to, every time somebody fired up a JavaScript client, it would create that ephemeral consumer and kind of start at the beginning for that particular whiteboard room that we were in and consume all those messages, draw it on the screen, and then use the consumer to kind of keep up with the live updates. That's a great example of using an ephemeral consumer because somebody closes their browser and we want that to be cleaned up, right? But if you're building a web service or like a data processing pipeline, it might be really important to have a durable consumer in place to be able to kind of keep track of where you last left off. And so you have both options here.
Correct. So another thing to mention briefly, just like Kafka, right? Jetstream always delivers the messages to you in order, right?
Mhm.
In Jetstream, messages are put into the stream. They all are into the stream. There's just one order of all the messages into the stream. And when you create consumers, ephemeral or durable, iterate through the messages, they come to you in order exactly the same. Uh, we probably get into that a little bit later, maybe in more detail, but
Yeah, because ordering semantics
essentially,
can be tricky, right? Because it's not just
yeah, yeah,
about it's not the order that they're persisted in, and it's not even the order that they're delivered. But as soon as you start dealing with things like errors, how do we guarantee that a consumer
that's
is
right.
is properly consuming messages in order? I think
And that's exactly the next topic we're talking about, which is queue and topics.
cool.
Um, Last thing to mention here as well before I forget, flow control, right?
Mhm.
Actually, Jetstream consumers are flow controlled. And because we undercover the covers support two kinds of delivery types for consumers, push and pull, right? Um, you can actually have two different types of flow control. So flow control means essentially, you have a lot of data into a stream, and you have your client applications that are interested in receiving that data and process it as quickly as possible. The problem is that typically you receive the message and do something with it before going to the next one.
Mhm.
While your stream may have a bunch of messages already in the stream ready to be sent with you, right? So what you want to avoid is overwhelming those client applications by the server sending them the data in the stream too fast, right?
Mhm.
So for that, Jetstream has forms of flow control, and two forms. One is one too many, which means that when you have a durable consumer, right, you have a stream, and let's say you have five applications getting the messages distributed between them, right? You can say, I want to not send more than a certain amount of messages maximum at a time, right? Before I wait and hear back from those consumers that they have consumed those messages, and I start sending new messages, right? Again, the whole idea is flow control, avoiding overwhelming your consuming application. So that's one too many flow control.
And is that
And then
max axe pending? Is that
that,
is that the
that is
schedule
correct.
you use?
And I will explain a little bit how the acts work in the next part about queue versus topics.
Cool.
But indeed, it's the maximum number of acknowledgements pending at any given time that you can control. Uh, and then if you are using a pool consumer, and push pull here in this case refers to the interest model, meaning that push the messages are sent ahead of time if you want, using pub-sub delivery underneath the covers, while pull, the messages are only sent on demand when the application says fetch me the next messages, the next n messages in the batch, and it will only send the messages to that guy at that point. So demand driven if you want. And so if you use pool consumer, you have, as well as this one to many flow control that still exists, a one to one flow control, right? So if your pooling applications fetch, like, let's say, a batch of up to 10 messages at a time, right? You know that each application will be a maximum of 10 messages sent ahead to it before it can process them and acknowledge them, and then get, or in this case, fetches, pulls new messages again, right? And gets new messages, the next messages in. So interesting in the fact that sometimes you do want this one-to-many flow control, sometimes you want that one-to-one flow control. In the case of Kafka, it's only pool. So you only have one-to-one flow control, but there's no concept of one-to-many flow control of sorts, right?
Right. Yeah, that's really interesting, and I think there's plenty of cases where you'd want to work through either of these. So Kafka doesn't have
Right. And
push.
to be fair, most cases, most people, you should not have to worry as to should I use push, should I use pull, and all that. And we are just came out with a new version of the JS API that we call the so-called simplified JS API, which is much better improvement on what was there before because, amongst other things, it totally hides those subtleties and underneath the cover, details from the user. You just create consumers and you have different ways to consume or iterate over the data without having to worry whether pull or push is best or anything like that, right? It does all that for you.
Right, right. So yeah, it sounds like in most cases that pull is generally a pretty
Typically,
good pattern.
yeah,
There might be
yeah,
cases from either a flow control perspective or a scaling perspective where a
yeah,
push might make sense. But you have both options in NATS, which is
right.
helpful.
And the last thing to mention, if that wasn't clear here, is that you can create as many consumers on you as you want on the same stream, right?
Hmm.
Each consumer will iterate through its own set of all the messages in the stream. So you can certainly do that if that's what your use case calls for.
Yeah, kind of it brings about that same concept that you've been kind of saying over and over, where a consumer is really just kind of like a view on a stream,
Hmm.
a very specific
Exactly.
view of
And you can
view of
have
that
multiple
flow.
views on the stream, right?
Yep.
And you know, and we'll get to that next. But if you have things like people deleting messages from one place, it's reflected obviously into all the consumers that are
Hmm.
iterating of that stream, right? It's
Yeah.
always in sync, with the data in the stream at any given time.
Yeah. Awesome. Awesome.